This video is on the objective, use the sum and difference formula for sine. Alright, this is number 1, so the first video on a question from your Newton Alta homework related to this objective. So before I get into the question though, I'm going to refresh our memories here. Let's hopefully you've read through section 9.2 already of your OpenStax book, or maybe you looked at more instruction in your assignment. But I want to bring up, what are these sum and difference formulas for sine? The sine of a sum of two angles and the sine of a difference of two angles. All right. So here are I'll write them out here. So the sum and difference formulas for sine. So I'll start with the sum formula, and you'll see that the sum and the difference formula are basically the same, with just the signs change, plus or minus. So if I'm taking the sine of the sum of two angle measures, so say angle alpha or A plus angle beta. All right, so I have an angle called alpha, an angle called beta, and then we've added them up, 30 degrees plus 45 degrees or something. Added them up to make 75 degrees, and then find the sine of that new angle. So what's the sine of alpha plus beta? Well, again, hopefully you've done your reading, and I'm just going to go into what the formula is, and then we'll use it. It's the sine of the first angle, right, the sine of alpha, multiplied by the cosine, cosine's popping in here, the cosine of the second angle. So we have the sine of alpha times the cosine of beta plus, alright, so the sine of a sum is also a sum. Alright, so plus, and then you just switch the angles. Do the sine of beta times the cosine of alpha. Sorry about the tightness there. So it's the sine of the first angle times the cosine of the second angle plus the sine of the second angle times the cosine of the first angle. And then the difference formula is, the only thing that changes are the pluses. The pluses become minuses. All right, so the sine of the difference between two angles, right, say alpha minus beta, is the sine of alpha, right, the sine of the first angle, times the cosine of the second angle, beta, then, minus, 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 then the sine of beta, the sine of the second angle, times the cosine of alpha. Again, all you're doing in the second term is switching the angles. Okay, so keeping these in mind, let's go to the question. See how we're going to use one of these. All right, and again, if you want to see more, click on more instruction, look at their videos, their examples, their notes, and maybe that'll help you. All right, so we're given the following. We are told that the cosine of some angle called A is negative 7/25. All right, and angle A is an angle that ends in quadrant 3, in standard position. The cosine of angle B is negative 12/13, right? This other angle called B, and angle B is an angle that ends in quadrant 2 when you draw it in standard position. And what we're asked to find is the sine of angle A minus angle B, right? So if we were to take these two angles, A from quadrant 3 and B from quadrant 2, and subtract them to get a new angle, right, called A minus B, what would be the sine of that new angle? All right, so I'm going to draw all this information up on a separate sheet of paper, and we're going to draw lots of pictures, right? And we've done this before. You've drawn, now not this particular problem, but we've done drawing of angles before in previous videos. So first I'll start with angle A. right, the angle called A. What information are we given about angle A? Well, we're told that the cosine of angle A is negative 7/25. Right? And we're also told that angle A is in quadrant 3. Right? It ends in quadrant 3. So I'm going to draw a picture of angle A. So here's the xy coordinate plane. And remember, when you're drawing a picture of an angle in standard position, you're starting from the positive x-axis as your initial side. Now, quadrant 3 is over here, right, the lower left quadrant. So again, I could have this go counterclockwise, clockwise, doesn't matter, as long as it ends in quadrant 3. Right? So I'll just take a counterclockwise, a positive angle. There's angle A that I've just drawn, as long as the terminal side is in quadrant 3. Right? And then remember what we do with these in our nice pictures. I take a point on the terminal side here. It's got some x coordinate and some y coordinate that I don't know. And I draw a perpendicular segment to the x-axis, right? And I create this right triangle. Right? And then this angle here is called, the reference angle. I'll call it R. And I would like, since the cosine of A is, negative 7/25, I would like the cosine of this reference angle to be 7/25. All right, but we're in quadrant 3, so the larger angle, right, has a cosine of negative 7/25. All right. So the side lengths of this right triangle. Remember cosine in a right triangle is adjacent over hypotenuse. So this adjacent length, right, the length adjacent to the reference angle, this length here is 7, and because it's left of center, I'll just call it negative 7, and there's the x-coordinate of this point I chose, negative 7. And the hypotenuse has a length of 25, and that was the value of that r. Remember, r was the distance from the point on the terminal side to the origin, and that was always a positive number, right? So I'm not going to make that negative 25 or anything, just positive 25 distance. And then I could use the Pythagorean theorem to find this y coordinate, right? The length of this side here. So using the Pythagorean theorem, we have negative 7 squared plus y squared equals 25 squared. So we have 49 plus y squared equals 625. Then y squared would be 576, right? Subtracting 49 from both sides. Then taking the square root, this will be plus or minus 24. Right? The square root of 576 is 24. But I'm not using both those. We're going to use the minus since we're in quadrant 3. I'm going to use the minus sign because we're in quadrant 3 and this is a y coordinate. Right? So this is negative 24. And the y coordinate of this point I chose is negative 24. Great. Now I have all the information I need to find the value of any of the trig functions of angle A. All right, so here's my picture of angle A. I'm going to do the same thing with the other angle they talked about, angle B. All right, and I'll keep referring back to these pictures, but so now let's look at the information they gave us about this other angle. All right, this angle B. Now, they told us that the cosine of angle B was negative 12/13. And they also told us that angle B ends in quadrant 2. Okay, so like for angle A, I'm going to draw a picture of angle B. Start at the positive x-axis, initial side. And then it doesn't really matter which way I go, as long as I'm ending in quadrant 2, right, this upper left quadrant. So I'll just draw this angle here. There's angle B. And there's the terminal side, right, it's ending in quadrant 2. And then just like the last picture and all the pictures I've drawn of angles in standard position, I pick a point on the terminal side. I take this point here on the terminal side, right? It's got an x coordinate and a y coordinate that I don't know yet. I draw a perpendicular segment to the x-axis, creating a right triangle. And this acute angle here, right, the angle formed by the terminal side and the x-axis, that's the reference angle. I'll call it R for reference angle. And I would like to set up the sides of this triangle so that the cosine of the reference angle is 12/13, right? Because the cosine of my larger angle was negative 12/13. The cosine of the reference angle must be positive 12/13. Now again, cosine is adjacent. So this adjacent side would be 12, and again, since it's left of center, I'll just call it negative 12, and that would be the x-coordinate of this point. Over hypotenuse, right? So the hypotenuse has a length of 13, so that's the r, right? R equals, and again, it's a positive value, positive 13. And then one more time here, I don't know this y-coordinate. I don't know the length of this opposite side of the reference angle. So using the Pythagorean theorem, we have negative 12 squared plus y squared equals 13 squared. So this is 144 plus y squared equals 169. Subtract 144, we get y squared equals 25. So then y could be positive or negative 5, right? Square root of 25, but can't use both of them. Now this time I'm in quadrant 2. So we're going to use the plus, right? Because I'm in quadrant 2 and this is a y coordinate, right? Y coordinates in quadrant 2 are positive. So I'm getting rid of that minus sign. This is positive 5. This has a length of 5, that opposite side. And then the y coordinate of this point that I chose is 5, right? So now I have the value of x, the value of y for the point on my terminal side, and I have that r, right, the distance to the origin. So now I have all the information I need to find the value of any trig function of angle B, right? I could find the sine of angle B, the tangent of angle B, whatever. All right, so I've now got all the information I need about angle A. I've got all the information I need about angle B. Now we can find what if I subtracted those angles. Now we're looking at angle A minus B. Now I don't know how big A was. I don't know how big B was, so I don't know how big A minus B is. But using the information about angle A and the information about angle B that I've drawn, I can tell you what the sine of this angle will be. All right? I don't know how big it is, but I can tell you we can find the sine of angle A minus B. And this is using our difference formula. All right, so remember I had it written up earlier, but with alpha and beta. Remember the sine of A minus B is the sine of the first angle times the cosine of the second angle, right? So the sine of angle A times the cosine of angle B minus, right? This is the sine of a difference is a difference, and then just switch the angles. Take the sine of angle B in this second term times the cosine of angle A. So all I need to know now are what's the sine of angle A, what's the cosine of angle B, what's the sine of angle B, and what's the cosine of angle A. All right. So the sine of angle A, let's start with that. So that means I'm going to go back to that picture I drew with the information about angle A. All right, so here was the angle A picture. Now I know the cosine of A, but from this picture we can also figure out what the sine of angle A is. Now remember, sine of angle A, that's y over r, right? The y coordinate of a point on the terminal side divided by the distance to the origin. Hopefully you remember these relationships. So that's negative 24/25. Right. the sine of this angle will be negative 24/25. So that's what I'm going to put here. Negative 24/25 times the cosine of angle B. So this is about angle B. I'm going to look at my picture for angle B. Now, they already gave that to us, didn't they? They told us the cosine of angle B was negative 12/13. So that's what I'm going to put here. Negative 12/13. All right, then we have minus, and now I'm doing the sine of angle B. Now this is about angle B, so I'm going to look at the picture that I drew involving angle B. Now we know the cosine, but from this picture we can also state the sine. All right, and the sine of angle B is again the y coordinate of that point on the terminal side, which would be 5 divided by the r, right? So that's 5/13. Positive 5/13. So I'll put that in here. Sine of angle B, 5/13. And then finally times the cosine of angle A. All right, now the cosine of angle A, that's about angle A. So I go back to that picture I drew about angle A. And they gave that to us, right? They told us the cosine of angle A is negative 7/25. All right, and then we can simplify this. All right, now 25 times 13, that'd be 425. And then 24, now this is negative times negative, so that's going to be positive. 24 times 12 is 288. Right. Now, we have minus, and then over here, this fraction. Now the denominator is the same. It's 13 times 25 again, so they're both over 425. And then 5 times negative 7 is negative 35. And what we're doing here is we're subtracting a negative. So that's adding. So they both have a denominator of 425. And then 288, minus negative 35 would be 288 plus 35. All right, and if I add 5 to that, that'd be 293, and then 30 more would be 323. All right. And it said give your answer as a fraction, and here we go. This is let's see. I think that might be simplified. I'm not going to bother. I'm going to enter that and see if they take it. But this should be the value of the sine of the difference of those two angles that I was given. If I took those two angle measures, I don't know what they are, but I do know that if I subtract them, I can tell you what the sine of that new angle will be. All right. So then back on the question, I'm entering the fraction, 323 over 425. Oh, they must have simplified it. It must be simplified. All right, so let's simplify that fraction and re-enter it. All right, so I'm gonna pull up the calculator. I'll have the calculator do that for me. So let's take 323 divided by 425. Maybe I did my arithmetic wrong. All right, yeah. So it's definitely can be simplified. Let me just double check that 25 times 13 should be 425. Oh, yep, did it wrong. Did it wrong. See, glad I caught that. I mean, they told me to catch it. Yeah, that's 325. My mistake. 325. So it should be 323 out of 325. My apologies. Yeah, so 323 out of 325. So sorry. Yeah, and I don't think that simplifies to anything. Let me change that to a fraction. Yeah, 323 out of 325. So let me go back. All right, so There you go. Double check your arithmetic, folks. Double check your arithmetic. There's a good lesson there. So 323 out of 325. Aha. There. That would be the sine of the difference of those two angles. Wonderful. Okay. And then again, they go through the same, see, it's the same calculation I went through, only they did 25 times 13 correctly. That looks like they simplified this first. I didn't simplify it till the very end anyway. But still, they did the same calculation here. See the sine of a difference formula. All right. So there's a good lesson for you, folks. Double check your arithmetic. I should have, instead of trying to rush it like I did, double check your arithmetic and double check your work before you submit your answer. Alright, so hopefully watching me do this and make that mistake and fix it and all that, hopefully that helps you out when you're working on this kind of a problem on your own. And I would highly recommend also having the sine of a sum and sine of a difference formulas memorized, to make these a little quicker for you. Alright, thank you for watching.